Hello and welcome. We have started a new series called as Complete Geography by Pratik Kode. We are going to discuss world geography in this video. We are going to follow the NCRT, and this video series will be important for the various exams such as UPSC, CAPF, CDSE, NDA, and all the government exam where there is the mention of GS, General Studies. So now we have to understand that the first chapter that we are going to start is Origin and Evolution of Earth. Origin and Evolution of Earth. As per our NCRT and its index is concerned, we are going to do Origin and Evolution, then we'll do Earth. Okay, so you will find that, and once you complete your this chapter, that is Origin and Earth, you'll understand that the topics that you have highlighted are already being covered here. Okay, so we'll start with the first, which is given in the book, and that is the Big Bang Theory. As far as the Big Bang Theory is concerned, it was given by Edwin Hubble. So first MCQ is here that Big Bang Theory was given by Edwin Hubble. As far as Big Bang Theory is concerned, it is also called as expanding universe hypothesis. Expanding universe hypothesis. So by the name itself, you can understand that what it tries to say. So according to this theory, that all matter was concentrated in a very tiny ball of unimaginable small volume with infinite temperature and infinite density, and then this tiny ball exploded, and the matter, it scattered throughout the universe in the unproportionate quantity, and then you see that this matter which was basically scattered in the universe, they started star formation. uh, Due to this uneven distribution of matter and energy, the whole universe led to initial density differences, and that resulted in gravitational force because there was difference in energy and matter, and this led to the formation of initial gravitational force, and it causes the matter to get down together based on the development of galaxy, and hence each one of them basically developed into galaxies. Now, this galaxy star starts to form an accumulation of hydrogen gas, okay, and this very large cloud, okay, of the gases, we'll call it as nebula. Okay, so this is called as nebula. It is the localized clump of gas. Okay, so that is the nebula. Now, as far as the galaxy was concerned, this led to the formation of gaseous body, thereby formation of stars. Now, after formation of star, there are various theories which are uh, important for the formation of planet. Okay, and you have to understand that these are important as far as and geography optional is concerned. For us, it is not given in the NCRT, and you can simply, if you want, you can go with the Google to find this. And I don't think that these are some of very important topics, but for uh, little exams or for the state level exams, there this question, that is formation of planet. For example, nebular hypothesis. Then there is a cigar shaped hypothesis. Okay. Then there are various hypotheses which was given. Your task is to find out who gave this type of hypothesis. So that comes under the formation of planets. Now, the stars are localized lump of gas basically, right? So within the nebula, gravitational force within the lump led to the formation of core to the gas cloud, and a huge rotating disk of gas and dust developed around the gas core. Now, as this was basically in the gas core, so this type of dust it developed around this gas core, and now this gas cloud it condensed, and matter around the core developed into, no, this started condensing, okay, this material. And then they will unite with each other, collide with each other, and then there will be a formation of a body. Okay, this round object in process of cohesion, this led to a planetesimal. Okay, planetesimal. So these are nothing but a number of little bodies which will be floating in the space, and these large number of small planetesimals came together to form a fewer larger body in the name of planets. Okay, so from nebula we started nebula we came out to the gas cloud, and from gas cloud we came to the planetesimal, and from planetesimal it led to planet. Now we have to understand the solar system. As far as our solar system is concerned, we have a sun, that is star, and 8 planets, and the number of moons are basically different according to the different hypotheses. Okay, okay. The next one, it is important to study various planets, right? For example, this is our sun, and Mercury, Venus, Earth, Mars. Then there is Jupiter, Saturn, Uranus, Neptune, and the dwarf, that is Pluto. So you will see that till here, that is Mars. Okay, this is nothing but Mars, Earth, Mercury, Venus, Jupiter, Saturn, Uranus, Neptune, Pluto. Pluto is not a planet, basically it's a dwarf planet. So here, that is between the Mars and Jupiter, there is an asteroid belt. Okay, so you will find that the little bodies, they are revolving around sun, in particular this between Mars and Jupiter. Okay, so if a question comes that where this asteroid belt lies, that is between the Mars and Jupiter. Okay, the next thing which is important here is that this planets, that is from Mercury to Mars, is called as terrestrial planets, or it is called as inner planet. Okay, and these planets are called as outer planet, or it is called as Jovian planet, or also gaseous planet. Okay, Jovian, gaseous, and outer, inner, and terrestrial planet. Now we'll start with each one of them. Okay, so let us start with each one of them separately. So the first thing that we are going to discuss here is our only star, that is sun. Okay, so as far as sun is concerned, the sun is consist of three parts, which is photosphere, chromosphere, and corona. Okay, this corona is different from the corona which have came out of China. Now, photosphere is a very bright outer layer. Okay, bright outer layer, and it emits most of the radiation. It emits radiation. Most of the radiation is emitted from photosphere. Now, just above the photosphere is the chromosphere, and it is relatively thinner layer, and here the burning of gas takes place in chromosphere, and it is relatively thinner. Corona is basically a distinctive atmosphere of plasma that surrounds sun and other celestial bodies. So that is the corona. As far as the sun is concerned, there are instances of finding the sunspots. Okay, so there are certain properties which are related to sunspot, and this topic of sunspot is important even for UPSC exam. So, what basically sunspots are, why they are darker, what is the magnetic field around them, uh, does this phenomena occurs regularly? These are the questions which are associated with sunspot. Your task is to find out that what sunspots basically everything related to sunspot, and this is important, believe me, you will find it very interesting, and hence I'm leaving this topic onto you because this topic is very very interesting. You will love to read about it and then understand it by yourself. Now there are solar flares. Okay, so solar flares basically are the magnetic storms. So whenever the solar flares happen, uh, the satellites, basically the communication between the satellites are disrupted. So this is this solar flares, which is magnetic storm on sun, which appears to be very bright spot. Okay, solar flare, very bright spot. Okay, and it is a gaseous surface eruption. So basically gases are erupted from the surface. So that is solar flare. The next uh, topic in the discussion is our first planet, that is Mercury. So if we are talking about Mercury, there are very little things that are important because you see this is introductory chapter for the book, and hence it does not have that much of significance. If there are any topics which are important, we are covering it, and from the next chapter onwards, this topic will become very important. So for Mercury, it is the smallest and closest. Okay, then for Venus, you have to remember the twin planet of Earth. Venus was in news basically because there was a chemical which was found, which was traced in the atmosphere of Venus, which are the result of anthropogenic activities, or which is a result of human, like not human, sorry, result of a biochemical process. For example, something on this planet is there. That is what have been concluded from the research. So Venus, Earth's twin. Then there is Mars. Mars basically it has an atmosphere. Mars has an atmosphere and that is very thin, and it has CO2, that is carbon dioxide, and it is red color which comes from iron. Then there is Jupiter. It is the largest. It composed of three gases: hydrogen, helium, and methane. Okay, hydrogen, helium, and methane, and it has circular light and dark bands, and it also has rings. It also has rings, the way Saturn has, but Saturn's rings are more prominent. Okay, hence it becomes the peculiar characteristics. But here you have to understand and remember that even Jupiter has rings. Okay, earlier Jupiter had the highest number of moons, but now which is replaced by Saturn. Now Saturn has the highest number of moons. Saturn basically it has three rings. Okay, it has three rings. That is important. Uh, It is the second largest, of course, largest being the Jupiter, and it is mostly hydrogen and helium. and highest number of moon. Highest moon. After Saturn, Uranus is important. It is bluish green. And remember this thing, because when particular planet is being talked here, the characteristics is this, that is bluish green. And you have to remember that it orbits east to west. So is it the only planet which revolves around sun in east west direction? You have to find that out. As far as Uranus is concerned, yes, it orbits from east to west. Now you have to find that whether it is the only planet or there is another planet. The next is Neptune. Neptune has two satellites. It is colder, okay, and it is also called as the twin of outer solar system. Okay, this Uranus and Neptune, they're also called as twins of the outer solar system. Then there is Pluto, but it is a dwarf planet. There are various criteria for a planet to be classified as a planet. Okay, and Pluto does not qualify those criteria, so it is not a planet anymore. It is a dwarf planet. Now, important topic is here, which is the Kuiper belt. So the way we have asteroid belt between Mars and Jupiter, after basically Uranus, this Neptune also little bit comes under Kuiper belt. So it is a ring of debris, okay, and it's cold, okay, because there is primarily ice. Now, anything, remember anything which is basically found in the anything which is basically seen as a body outside the Earth's atmosphere, we call it as celestial body. Then there is a basic difference between certain topics. For example, asteroid. So asteroid is basically the rocky body orbiting the sun, orbiting orbiting the sun. Large number of these, ranging enormously in size, are found between orbit of Mars and Jupiter. Okay, as we know that asteroid belt is there between Mars and Jupiter. Then there are comets. Comets are basically the celestial body with nucleus of ice and dust. And when it moves from us towards sun, so you see that the gases basically they are releasing, and hence it appears as it has tail. Then there is meteors. Meteor is an asteroid or any other object that burns and vaporizes upon the entry to the Earth's atmosphere. Now, meteor are commonly known as shooting star. Meteors are commonly known as shooting star because there will be description, and you will find a mention of it is also called as shooting star or known as shooting star. Okay, and then there will be option like meteors, meteorite, meteoroid, and asteroids. Okay, now you have to find that okay अभी इसका क्या करना है. Meteoroid, meteorite, astronoid, and astrolabe, and then meteors. So basically it is about meteorite. Now there are a few things that is done here. Now if some meteors they survive through the atmosphere and land on the surface, we call it as meteorite. Meteorite. Okay. If something, suppose this is a meteor in the atmosphere. Okay. First it is asteroid in the space or celestial body. Then when it comes to the Earth's atmosphere, it will start burning. We'll call it as meteor. Okay. And when this meteor will make an impact on ground, it will be called as meteorite. Okay. That's it. Now we have to start that from the late Proterozoic area. We'll start from the late Proterozoic area. Okay. Late Proterozoic era. You see the first skeletal element, then first animal traces, and first soft body metazoans, they were found. So that is the area where we start. It is around 650 million years ago. And we find the first dinosaur in the Triassic. You must have seen this Triassic, Jurassic. Okay, so that is the area. And then evolution of human. It started very recently, which is Quaternary, where evolution of human started. Okay. Now the next topic or the second chapter of this is interior of Earth and associated factor. See, as far as the evolution of Earth is concerned, we have to understand that it is very dynamic phenomena, and no one thing can be correct at all the time. Okay, so we have to understand that there are multiple chances of multiple things being correct. So here we'll start with the evolution of Earth, but before that we'll do a little study of certain topics of Earth, certain areas of Earth, and we will name it. Okay, this is core, outer, inner, mantle, outer, inner. Okay, okay. The uppermost layer, crust. This is an outdated theory. Okay, Cial and Sima. Cial, that is the crust, the continental crust, and Sima, oceanic crust. So for continental crust, silicon and aluminum, which are lighter in density, and then uh, silicon and magnesium, which are denser, or which whose density is more than the aluminum, and hence it is the part of oceanic crust. Basalt and granite. So remind, we'll deal with this then later in this chapter. I will just write down in order to remember that. Now, as far as the Earth is concerned, the evolution of lithosphere, the Earth was mostly in the volatile stage during the primordial stage. Due to gradual increase in the density and temperature inside, Earth increased. As a result, the material inside started getting separated, and depending upon their density, this allowed heavier metals like iron, nickel to sink towards the center of Earth, and the lighter ones like silicon and aluminum, magnesium, etc., they move on the top, that is on the crustal or upper mantle side. Now you see the density of the material continuously goes on increasing from crust, mantle to core. Okay, so this later led to the development of outer surface in the form of crust, that is Cial and Sima. Now, evolution of atmosphere. There are three stages of the evolution of atmosphere. In the first stage, there is a loss of primordial atmosphere. Okay. In the second stage, there is an evolution of atmosphere. Third is when the living creatures started coming in the world and they modified the atmosphere, and that is something the third phase of first, second, and third phase. Now, early atmosphere. The early atmosphere, it has hydrogen, okay, water vapor, water vapor, nitrogen, methane, ammonia, NH3 or NH4. I don't know. I'll just write. I think NH4 it is. Ammonia and very little free O2. Okay, very little free O2. This process through which the gases were outpoured from the interior. Now, this gas which were trapped here were coming outside. Okay, and okay, this is basically the atmosphere and going to into the atmosphere. So this process is called as degassing. Okay, so this process is called as degassing. The next thing is that continuous volcanic eruption contributed water vapor and gases to atmosphere. Now, due to the process of degassing, we got a lot of H2O, that is water vapors in the atmosphere. We got various gases which were trapped in the core mantle and the upper mantle portion. After this degassing, the next topic is hydrosphere. As the earth cooled, the water vapors which were released from the core mantle and the upper mantle, it went to the atmosphere. Okay, now in the atmosphere, the carbon dioxide in the atmosphere also got dissolved when there was raining. Okay, and the depressions which was there. Okay, so the depressions which were there were filled by raining, and now this depressions will make oceans, seas, and lakes. Okay, so this rainwater falling into surface got collected in the depressions, and then it led to ocean. Now, Earth's atmosphere were formed within 500 million years from the formation of Earth, and around 2500 to 300 million years before the process of photosynthesis started. Million years ago, the process of photosynthesis started. Ocean began to have a contribution in oxygen through the process of photosynthesis, and eventually ocean were saturated with oxygen, and 2000 million years ago oxygen began to flood the atmosphere, and that is the situation which happened. Now, the structure of earth, if we are basically talking, we draw a diagram. Okay, so it consists of crust, that is the upper layer, then mantle, and the core. There is also area called as lithosphere. So basically lithosphere is nothing but the crust plus little area of upper mantle. We'll call it as lithosphere. Crust varies between 100 0 to 100 kilometers. Okay, so we'll start with the crust. Okay, crust. So crust is the outer thin layer with total thickness between 30 to 50 kilometers. There is oceanic and there is continental crust. Oceanic crust is basically 5 to 30 kilometers, and continental crust is about 50 to 70 kilometers. Consider, just take an example. Okay, if this is Earth, consider this is to be Pacific Ocean. Okay, This is the area which is already filled by water, and let us assume that this is the limit of crust. Okay, usually the size is inappropriate, but I'll just, in order to explain, you see here, this is the place, okay, where I'm highlighting right now. This is the place. You'll find that there is very little space as compared to this. Hence, the continental crust is thicker than oceanic crust. The continental crust is thicker than the ocean. You see this crust, it forms around 5 to 10% of Earth's volume. And we see a Moho discontinuity. It is between the crust and asthenosphere. The asthenosphere is basically the upper portion of mantle. And when we will deal with the plate tectonics, we'll understand that these plates, when they interact with each other, okay, so when they interact with each other, there is a subduction of plate, and this plate goes to asthenosphere, and then from here the magma will come up in the form of lava. So that is how asthenosphere work. When we'll do with the volcano, we'll have a complete discussion on that particular topic. Now, the continents are composed of Cr and oceans are composed of Cma, that is silicon and magnesium. But this is an outdated theory, but still it is most of the time it is talked about. Then there is mantle. Mantle, it extends to the depth of 2900 kilometers, and the crust and the uppermost part of mantle are called as lithosphere, the way we have talked. Now the lower mantle extend beyond the asthenosphere, and it is in solid state. And the upper mantle, it is basically a little uh, area where density will start increasing. Now, the density of mantle is around 2.9 to 3.3, and it is composed of solid rock and magma. The upper portion of mantle is called as asthenosphere. Okay, the upper portion of, if this is the crust, so this, that is the upper portion of mantle. This is core, this is mantle, and this is crust. So this upper portion of mantle is called as asthenosphere. It is considered that it extends up to 400 kilometer, and it is the main source of magma. So asthenosphere is the main source of magma. Now you also have to understand that as mantle. So this mantle is around 83% of the Earth's volume. The next is crust, core. Okay, so as far as the core is concerned, it lies between 2900 kilometers to 6400 kilometers approximately. Now it accounts around 16% of Earth's volume, and it has highest density, as we talked in the last uh, session of this particular video only, that the heavy material, it sunk to the bottom of Earth, to the core of Earth, and the lighter material, it went above. And that is how the evolution of core is concerned. It is made up of iron and nickel, and hence it is also referred as Nife. The area which separates core and mantle, there we find a gap which is called as Gutenberg's, okay, discontinuity. Discontinuity, Gutenberg's discontinuity. See, as far as the core is concerned, it is also divided into outer core and inner core. Inner core is basically solid. The outer core is molten or basically liquid state. Okay. Now discontinuity is there, which is Gutenberg discontinuity, which lies between the mantle and outer core. As far as the composition of Earth's crust is concerned, that's important. You just have to remember this thing. Ossi Alpha, Casa Poma. That's it. If anything comes from this topic, that is composition of Earth's crust. Okay, composition of Earth's crust. So just remember that Ossi Alpha, Casa Poma. OC alpha, Casa Poma. O stand for oxygen. Okay. C is silicon. Al stand for OC alpha. Al stand for aluminum. F for iron. Okay. Then Ca, calcium, sodium, potassium, magnesium. Okay. Done. So the composition of Earth crust is OC alpha, Casa Poma. The next is chemical composition of Earth. Okay. So chemical composition of Earth. So, as far as the chemical composition of Earth is concerned, why don't you do that? The way I gave you the composition of Earth's crust, you come up with this topic, which is chemical composition of Earth. Okay. Now we'll start with the Earth's interior. We talked about these three layers. Okay, the core, mantle, and crust. Okay, but how do we know that these are the three layers? Okay, what is the qualities of these layers? What are how we know that this is the outer core is liquid and inner core is solid? How do we know this thing? So we have to. This is not just a philosophy, right? It is a science. So it gives evidences. It demands evidences. So there are two types of evidences, and question may come on that: indirect evidences, direct evidences. See, as far as the direct evidence is concerned, you take an example of mining or volcanic activity. Okay, as far as mining is concerned, you have to understand that we cannot go very deep into the crust. Hardly we can go around 12-13 kilometers or little more than that, but our technology is not that developed for us to sustain that hostile environment. And as far as volcano is concerned, the records that we get is from the asthenosphere. Okay, so that is also something which is not giving us the clear pictures of the direct. Now we talk about the indirect one. Indirect one is important because question simply maybe if question comes from this topic, it will be like which of the following are indirect sources of information about the Earth's interior or direct. Now, as far as the indirect is concerned, we'll talk about the analysis of properties. Analysis of property, for example, PVT, that is pressure, volume, temperature. So with the analysis, they found that there is a difference in temperature, differences in volumes, and difference in basically density and pressure. So that is how they analyzed. Second, by meteors. When meteors they made contact with Earth and become meteorite, it provided the insight of the outer space. And Earth is also similar to the celestial body if we are not considering us to be a human being or the habitants of world or Earth. If we are someone from Mars, Earth will also be a celestial body. So the celestial bodies are basically similar in their composition as far as the asteroids are concerned. And when scientists get an opportunity, they'll find it out through this meteors or meteorites. Then third is gravity anomaly. It means that on various places on Earth, the value of G is 9.8. Okay, that is what have been uh, given, but this is not constant. It varies. So this varying of the gravity, it is called as gravity anomaly, which gives us information, because see, this gravity depends on mass. Okay, and this mass is not uniformly distributed in the Earth's interior, and hence by that we can find out the various information through gravitational anomaly. Now, magnetic survey. Magnetic survey is important because it gives us various insights about the material minerals which are found in the earth, what are the basically gaps between them, and various other aspects of magnetic survey. When we'll do earthquake, we will realize the importance of various waves which are important in order to find the indirect evidences of earth's interior. And the last is seismic activity, basically earthquakes. Okay, these are the important sources about the interior of earth is concerned. Okay, now we talk about the motion of earth. So earth is basically with revolution, rotation. In short and crisp, rotation causes day and night. Revolution causes changes in season, seasonal changes. Okay. Now there are other aspects such as equinox, solstice, and I think these are not the topics which are important, but we will write down certain uh, dates which are important. Okay. So you can simply write down this September 22, 23. It is autumn equinox. Then March 2021, it's equinox, vernal equinox. Then there is winter solstice in December 2021, 21-22. And then there is summer solstice in June 2021. Now, what this solstice is, we'll talk about it in the further topics. Okay. So, as far as the rotation of Earth is concerned, we have to understand that first, Earth rotates from west to east, not from east to west. There is a planet which rotates from east to west, and which is that planet? I had asked you to find it out. It takes approximately 24 hours for Earth to rotate. See, a very important question or very common question is why there is a 29th day in February every 4 years. After every 4 years, why it is so? This is a very common question. Okay, as far as this is Sun and this is Earth, it does not what we say when will it will rotate around Earth. At the same time, it will also rotate when it will revolve around Earth. At the same time, it will also rotate around itself. Okay, so this is the first thing. Second is that it does not take 24 hours total. It takes 24 hours and certain minutes. Okay, and we have to understand that this certain minutes is around 6 hours per year. And when 1, 2, 3, and then this is the fourth year, when fourth year comes, it becomes total 24 hours. And 24 hour, it means 1 day, and this 1 day will be added to this 29th February. Okay, Now we have to understand that this is if this is our Earth, okay, and this is the Sun, okay. Okay, that's not appropriate. If this is the Sun and this is our Earth, you see that due to its rays, this portion will be bright, and here will be day, here will be night. So this line which divides the Earth from day and night, it is called as circle of illumination. Circle of illumination. Now there are two things which are very important as far as this topic is concerned. The first is that the angles that it makes with normal. With normal, it makes an angle of 23.5 degree, but with the orbital plane. Now you see that this Earth, it is also revolving around Sun. So if you put that into a frame, that becomes orbital frame. Okay. So this is the orbital flame and frame. Here it is 66.5 degree. Okay. So you have to remember that this is the angle that it makes. If and you know that this Earth is tilted across its axis. It is not like this. Okay, it is tilted across its plane, and hence you have to remember that with normal it makes 23, and with orbital plane it makes 66.5 degree. This is very important if anything from this topic is there, which is this, that is the angle that Earth makes with normal is 23 and a half, with orbital plane it is 66 and half. Okay, now we'll talk about the revolution. As far as the revolution of Earth is concerned, the motion of Earth around the sun and its orbit, it's called as revolution. मतलब जो अर्थ है अपनी, जो सन के अतराफ घूमेगी, that particular orbit will call it as revolution. At the same time, it will perform its rotation as well. Okay, all right. So this revolution, complete revolution, when this Earth will take a day, it will be making 364 days. Okay, plus 6 hours, that is 1/4 day. All right, and hence this 1/4, it is difficult to accommodate this 1/4, right? So what we'll do, we'll add this 4 1/4, that is 4 by 1, which is equals to 1, and we'll add it into a leap year. Okay, and we'll call it as a leap year, and hence it will be termed as 29th February. Clear? Now we have to understand a basic difference between latitude and longitude. So very confusing fact which comes into the picture is the latitude as well as कि कौन सा latitude है. So you have to remember that this is Earth, okay? Can you see this people? क्या ये लेटे हुए हैं, right? These people are लेटे हुए, and hence they are latitude. Okay, very simple. जो लेटे हुए हैं वो latitude. Clear? अब जो नहीं लेटे हुए हैं वो longitude. Okay, जो नहीं लेटे हुए हैं वो longitude. Clear? This is the basics between latitude and longitude. Now we'll discuss this was I think important for understanding कि कौन सा latitude है. So now tell me which one is latitude and which one is longitude. लेटे हुए latitude, खड़े हुए longitude. Clear? Okay, I hope it is clear, and I hope you will never find this. Okay, that is clear. Now we see that if this is our Earth, okay, okay. So now we'll discuss about the difference between latitude and longitude. Before that, you have to remember that this is 23 and a half, okay, in the northern hemisphere, 23 and a half in southern hemisphere, and this is the tilted axis. Now this Tropic of Cancer in the northern hemisphere, Tropic of Capricorn in southern hemisphere. Okay, this was basically just to tell you that ये होता है Tropic of Cancer, ये होता है Tropic of Capricorn, 23 and a half degree. That's it. Okay. Now the important topic and important discussion is on this thing, that is difference between longitude and latitude. Okay, so longitude and latitude. As far as the longitude and latitude is concerned, there are certain topics which are important and worth mentioning here. So the first about latitude is that the angular distance of a plane of north and south of the equator, of the Earth's equator, of Earth equator. Okay, the way we have drawn लेटे हुए latitude. Okay, this is latitude. As far as Earth this is concerned, जो लेटे नहीं है वो longitude. Okay, so this is north and south from equator. As far as longitude is concerned, it is basically east and west. Okay, so it is east and west of Greenwich. So we'll know what this Greenwich meridian is. Okay, Greenwich meridian is. So okay, now equator is the largest or longest latitude. Okay, and it is also called as 0 degree. Equator is 0 degree. As far as longitude is considered, the prime meridian is longitude. The prime meridian is basically a longitude. Next is longitude are named east or west of prime meridian, and all longitudes are equal length. See, all the longitudes from here, this are of equal length. All longitudes are of equal length. But here, important catch is that the distance between longitudes is decreasing from equator to pole. You see, this is what is happening. Okay, यहाँ पे distance ज़्यादा है, यहाँ पे distance कम है. They are merging. Okay, so here you have to remember that the distance between the longitudes, okay, distance between longitude decreases from equator to poles. As far as latitude is concerned, you see that the distance between the latitudes are constant. Okay, here distance is constant, distance is same, but the size of all the latitudes are not same. Here you see the size decreases here. Okay, the longest or the largest latitude is basically equator, and it decreases. So it is stated that equator has the maximum length, and it is called as great circle. Okay, equator is also called as great circle, and there are certain Tropic of Cancer, Tropic of Capricorn, Arctic Circle, Antarctic Circle, North Pole, South Poles, etc. are important latitudes. They help in determining the intensity of sunlight. मतलब क्या होगा ना कि यहाँ पे जैसे कि अब this is the basically the circle of illumination. So we see that अगर sun यहाँ पे sun है, okay, and this is the area which is encountered. So यहाँ पे जो sunlight होगा वो कम होगा relatively this area के. Okay, So that is how this thing, that is latitude, is gives us the difference. So the intensity of sunlight which is received at a point, that is what we get with the help of latitude. That is intensity of sunlight. See, both, that is latitude and longitude, are important for positioning GPS, okay, or Navic. So for positioning, latitude and longitude both are important. Now, longitude is important to determine time and date. For example, in India, Allahabad, okay, and that's 82.5, matlab 5.30 hours ahead of Greenwich. If this is Earth, if this is east, this is west. If you go from west to east, you add a day. If you go from, and you gain, okay, you gain and you add. If you go from east to west, you lose a day and you subtract. Okay, so this is what we'll do afterwards, but it is just remember that if you're going from western side to eastern side, you will add. Okay, remember that when a materialistic individual goes from western culture to eastern culture, it gains spirituality. When a western individualistic person goes to eastern civilization, it gains spirituality. And when the eastern world's man, he goes to western world, he loses his spirituality. Remember that this is not something which is right or approximately even right, but this is what you have to do for remembering that when a person from west goes to eastern civilization, it gains the spirituality. Okay, now longitude, the way we have discussed that this decreases towards pole and they are constant, they are lengthier here, okay, the distance between them is larger here and it decreases across the poles. All right, so this was the basic discussion about latitude as well as longitude. Next topic here is the seasons. See, there are various seasons, and a seasonal change, the very important thing is revolution of earth. As far as rotation gives us day and night, as well as we get various other things. But when revolution is particular concern, we get the changes in season. Then there are certain topics like summer solstice, winter solstice, equinox, etc. Uh, so we will just finish these topics, okay? And there is important topic which is called as Greenwich Meridian Time, from which we derived Indian Standard Time, and then there is also a concept called as daylight saving. Daylight saving. Okay, so we'll start with the summer solstice. Summer solstice. It is on 21st June in the northern hemisphere. Okay, when it is basically hot here. Okay, and the area will be Tropic of Cancer. Sun will be above Tropic of Cancer. Clear? Here, the Tropic of Cancer will get straight wave rays of light directly, and the poles will receive the slanting one. But similarly, this is the northern hemisphere. In southern hemisphere, it will be winter. Okay, it will be basically winter, right? And it will have a short night, sorry, long night and short day. Similarly, here, that is summer solstice in northern hemisphere, it will be long day and short night. All right. Now, the very important aspect here is that the area near pole, it receives less heat as the area which are near to the sun and slanting. Okay, so now The second is winter solstice. Similarly, the date will write, which is 22nd December. Again, northern hemisphere, southern hemisphere. Now on 22nd December, in northern hemisphere it will be winter. The sun will be above Tropic of Capricorn, and hence here there will be summer. Okay, because this is all you have to remember: northern hemisphere winter, southern hemisphere summer. Similarly, that thing it will be longer nights and shorter day. Here longer day and shorter nights. So this will be, then it comes equinox. Equinox, it means equal day and equal night. That is equinox. It comes on 21st March and 23rd September. 21st March and 23rd September, where both day and night will be equal. See, when it will be 23rd September, it will be autumn in the northern hemisphere, and it will be spring in southern hemisphere. Okay, here spring in southern hemisphere, and exactly it will be opposite in March. It will be autumn in southern hemisphere, and spring will be in northern hemisphere during 31st March. Now the next topics that we are going to discuss is, okay, so okay, so the last topic here is Greenwich Mean Time. That is Greenwich GMT. From that we'll derive Indian Standard Time. So equator is the centrally placed between both the poles, and it is any meridian could be taken to begin from the numbering of latitude. So basically, if this is latitude, okay, so any meridian like this can be the prime one. This can even be the prime one, because you see this is an Earth. If this is our Earth, you will find that, consider it to be 360. Okay, it's going like this and coming from there. Even if you'll take this, you'll find that everyone are similar. So, and when equator is constant, you can take this one, you can take this one, or you can take any one of them. So it doesn't matter. So what happened in 1884? You see, this is the world dominated by European powers, the and particularly London, Britishers. Okay, so the zero meridian, it was chosen to be Royal Astronomic Observation, which was there in London. Okay, which was there in London. Okay, so this becomes the prime meridian. It becomes prime meridian, which is equals to 0 degree. Then you have to remember that it is basically 360 degrees for 24 hours, meaning 15 degree for 1 hour. Okay, meaning 1 degree for 4 minutes. Okay, so this is clear. So now if this is the pardon me, if this is the prime meridian, okay, that is 0 degree, and if we are here, that is 82 and half, okay, 82.5 degree, then we will have to find out the difference between these two. Okay, what is the difference? And then we'll see that if how many degrees are there. Okay, and then we will multiply them accordingly and we'll find out. So for Indian standard time, which we have chosen as 82 degree, 82.5 degree east. Okay, so if you go to east, you will add. Okay, so during this particular part, that is east, which gains an add, and west lose and subtract. So we find that Indian time is 5 hour and 30 minutes ahead of Greenwich Mean Time. Okay, then there is international dateline, that is international dateline. Now you see that this is not straight. ऐसे सीधा नहीं है ये. Okay, it passes because what happened, there are certain islands which are here, and this is one country, so it becomes difficult. So what they did, they just made sure that this is either here or they're either here, if these are countries. So this is what they have drawn. So it is zigzag, that is India international date line. It passes through Bering Strait. Now where is this Bering Strait? You go and find in the map. Okay, then Fiji, for example, or Tonga, these are the islands which are you can find them here. That is how they were first divided. They would have divided if it would have been separate. So ऐसे हो जाता कि मुंबई में there is 29th Feb, and say Chennai में it is 28th or something like this. Just take an example. Okay, so that's it. Now the last topic, which is important here because it is worth mentioning that thing. It is called as daylight saving concept. तो इसमें क्या होता है, एकदम सिंपल से अंडरस्टैंड समझते हैं इसको. इसमें क्या होता है कि जो सनलाइट होता है, ठीक है, वो ऐसे नहीं कि साल भर में सिमिलर होगा. ड्यूरिंग समर क्या होगा कि जो सन है, इट विल टेक टाइम टू सेट डाउन. ओके, एंड इन विंटर ऐसे हो जाएगा कि 6 बजे रात हो गई है, बट इन समर यू विल फाइंड दैट इवन इट इज 7, but you'll still find sunlight. So this is nothing but the extra availability of sunlight, and that is how we use them accordingly in the concept of daylight saving. तो इसमें क्या होगा, when summer will come, and see, this practice is practiced throughout the world. It is not like something uh, uncommon. Okay, it is practiced. So what happened, जैसे ही summer आएगा तो they'll shift their clock 1 hour ahead, and when winter will come back, they'll make sure that the watch comes right back on time. So they'll just back on time. So what will happen during this summer, they'll get a daylight feeling. मतलब they'll basically the day will start typically. If it is summer, you will find that by 5:30 in the morning, you'll find sunlight, and even around 6:45 or say 7, you'll find the sunlight. But similar is not the case in winter. What will happen, you'll find that even if it is 6:15, 6:30, okay, you'll find little bit darkness in the morning. Even around 6:30, you'll find a darkness here. So there is a basic difference. So this is the difference which is being capitalized in the concept of daylight saving. There is a concept, this, like, India there is also demand that for northeast there should be a separate time zone, because if we consider the latitudinal extent of India as far as our country, India is concerned, you'll find that, okay, you'll find this thing that, so you'll find that this is very different. Okay, यहाँ पे 82 डिग्री है, उसके बाद इधर का टाइम अलग है, यहाँ पे टाइम है. So you'll find that there is a very much difference between these two, that is Gandhinagar and apna Arunachal Pradesh, and hence this is important for even India to consider of having a second time zone. So okay, for this video, as far as this video is concerned, we have uh, discussed the first introductory topic. Now in the second video when we meet, we'll start with the rocks and geomorphology and landforms, because I think this topic is important as far as our topics are concerned and exams are concerned. So thank you and stay tuned. If you haven't subscribed to this channel, I request you please kindly subscribe and support my efforts. Thank you.